Hey everybody. So today what I want to cover is the Revised Simplex. Okay? This is something that will set you up for if you do go on to pursue a career in programming, linear programming or operations research. When you hit your advanced linear class, you will be able to build a lot of things off of your understanding of some of the basic principles inside this Revised Simplex algorithm. Okay? Now, what is the Revised Simplex? I don't want to spoil it yet. It's another, well, really, it's just a revision on the simplex that has some very interesting things. So you know how to do the simplex algorithm. But let's see what we need extra to do the revised part of this. Okay? So remember the formulas to calculate any tableau, any table, for any set of basic variables. So if I told you x1, x2, and x3 are basic, you could follow these matrix multiplications to create the whole table, right? We just need to find the basic variables columns, invert them, and then we can multiply the original A, multiply the original B, get the cost on the basic, and front multiply those two things, and subtract off the original cost. And we could have the table just from doing a matrix multiplication. So I could jump to any basic feasible solution, right? And all you would need is the original information, the original matrix, original equations, and you would need to know what variables were basic. Right? The simplex algorithm uses these multiplications. I want to use one tweak to this though. So right in here, we're multiplying B inverse by the whole matrix A. The entire, remember that's the coefficient matrix. Everything that's being multiplied by x1, x2, x3, slack 1, slack 2, and so on. If I just wanted to get a single slice of this, if I wanted, say I wanted a single column, how would I do it? Well, I could still multiply by B inverse, but instead of the entire matrix A, I could just multiply by the original column in A. So we'll use a lowercase letter A with a subscript for whatever column it is. If it's the first column, A1, or if it's the column on x2, it'd be A2, so whatever column it is. So I could multiply that, and that would give me the updated column that will go there, okay? So that's one of the first skills. This is the way to just generate a single column. Generate a single column instead of the entire table, okay? Why is this useful? Well, here's what's useful about the simplex algorithm. Okay, you ready? This is a big deal. So this doesn't really cost a whole bunch computationally, right? Doing the simplex algorithm. But say that we had a whole lot of variables. That would be a bit of storage for the computer to have to manage, and it would store at each pivot and then do the calculations and do the pivots, and it would be storing all of this whole table, right, at each step of the way, eating up a lot of temporary memory. Well, using the revised simplex algorithm, we could, instead of having to keep up with everything, without keeping up with the entire table, we could just we really only need three things. The original table, so we just store that once. And then we just need to keep a list of our basic variables. So notice I have the word current here. So we need to keep updating it as we make pivots. And then as you change those variables, the matrix B and B inverse would change. So you need to keep the current, notice the word current again, B inverse. Those are the only things you need. I would need the original table. I need to know what's basic so I could get the current B inverse. Basically, I need the table, original table. Note, I'm trying to hint the word original here. And just B inverse, because I need to know the basic variables to calculate B inverse. So I would be able to generate or calculate any other part of this if I knew that. Because look up here. B is in the original table, right? the cost is in the original table. A is in the original table. If I know what's basic, then I know the cost of the basics, and I can make B inverse. So all of this would come from knowing what the current basic variables are in the original table. Okay, so that could save a lot of steps or solving. Okay, this is extremely useful in your computer solvers. Okay, now for small LPs, it's probably not going to make any difference. It's not that costly when it comes to temporary memory in your computer. But for larger ones, like most real-world problems, this helps a lot. It frees up a lot of memory and a lot of processing for your computer. Because then we don't have to do calculations over the entire every single pivot. We have to pivot every single member of these matrices, right? I won't have to do that here. I don't have to store as much. So, I mean, for instance, this is really useful. I'll go ahead and tell you when you have a lot of variables. So you end up with a really, really, really long table. Because if it's only got like 3 constraints, then the matrix B is only a 3 by 3, right? So you're just keeping it with the 3 by 3 matrix as opposed to like 3 by a million or something like that. So then I don't have to waste memory on that. Or if it's the other way, say it's a million by 3, you could just write the dual and that would turn it sideways, right? So don't forget all this other interesting things we've learned. I could turn it on its side by writing the dual and have the same structure. Even without this structure, it's interesting and it does save some memory, okay? So that's kind of the basic idea behind the revised simplex. The idea behind it, if I could get away with storing less, and also it saves your hand from cramping because you don't have to write all this out. How could I do it? How could I do this? Well, the neatest thing to do is in a few slides I'm going to work an example, okay? And I'm going to show you all you need to basically keep up with. And if you were to work it side by side, step by step, with the original simplex, you would see that this B inverse matrix that you keep updating is mainly the only thing you need, and you would see that it is sitting right there inside the simplex table. And that, wow, you could keep up with that, just those so many columns, as opposed to having to keep up with the entire table. That's pretty awesome. Okay, now I'm going to say I typed all this up. I don't know why. I just tortured myself and took a really long time typing this up. So I want you to be impressed with all my latexing skills. Some fancy stuff in here. But all this stuff's already typed up. So there's more typed up than you would have to show doing this by hand. Okay, so here's an example. I'm going to jump right onto an example. This is actually one we saw before. It should look familiar to you. So I've written out the table. Once again, be impressed, ooh and ah, at my skills of typing this. But here's this table, okay? Notice that we can start with the basic variables, the slacks, the trivial starting solution, right? And so this is also very easy. So then what's B? B is sitting right in here. Actually, B inverse is sitting right in there. So can you invert an identity matrix? Yes, it is the identity matrix. So piece of cake. Notice that's really easy. So if you were going to actually do this and say that you did not have these as your starting solution, you would have whatever. Say I just said these are the starting solutions. You would need to invert them to start it. Okay? So I got the inverse matrix, which is really easy from this identity thing. So look, if you were to solve this and you go about pivoting, these 3 columns right here are going to be what we keep up with to do the revised simplex, as opposed to the entire table over and over and over again. That would save you a lot of writing, right? Now we still have to figure some things, but that's pretty interesting. I think it's pretty neat. Okay, I think we're ready to start the revised simplex. I do want to tell you how we do things, like how to make a pivot. Okay, to make a pivot, we need to calculate the reduced cost. Obviously, we need to see what's most attractive, right? So we have to calculate the reduced cost. We don't know the reduced cost because we're not keeping up with the top of the matrix. We just keep the original. But how do I calculate the reduced cost? Oh yeah, that was really simple. It was this the cost of the basic variables times b inverse times a minus all the cost. Now for the first batch, we don't have to do anything because the reduced costs are sitting right here. Okay, that tells us which enters. Then we have to do the ratio test. So I just need, I need two things. I need the column. So say I tell you x1's entering. I need this column. I need it updated. And I need the right-hand side. When I do it, that's what I write in each step, is I write b inverse when I do this by hand, and I keep up with b inverse b. I keep up with the right-hand sides and have them pivot along. Okay? So that's pretty much all I have to write and carry this along. Now we'll generate a column every once in a while, and I stick it in here to do the pivot. So when I write this by hand, I'll generate that column that I told you that b inverse lowercase a, that sum column. And in here will be wherever we pivot on. And we'll make our pivot and update the b inverse and the right hand side. So we're still doing pivots the same way. We're still just doing, making this an identity column. But what we're keeping up with is b inverse and the right hand side. And some people don't keep up with this because you could recalculate that really easily. You could just multiply b inverse times the original, whatever the current b inverse is. But I keep it there because it helps me not to think too hard to make the pivot with it. Okay? Different textbooks do it differently. All you're required to keep up with is b inverse. All right? So then you do a ratio test. That's why you need this. And you need this column to do the ratio test to see which variable leaves to do your pivot. Okay? At each pivot, we will update the right b inverse. We'll update the right-hand sides, and we need to update the list of our basic variables. So you may still want to write out to the side, oh yeah, slack 1, slack 2, and x1. Write whatever's basic. Okay? Just for your own note keeping. All right? So you ready to try this? Now, I have this all typed up, so it'll be a little different than me doing it by hand. But, so we need to keep this handy, the beginning problem. Okay, so there we go. There's our b and our b inverse b. So can we calculate reduced cost? You don't really need to do it. Notice this is the same as the original cost. But anyways, for this first step, we don't need to. So what's most attractive? So you say, oh look, x1 is most attractive. So x1 should enter. So we calculated that cost really easily. You say, okay, x1's most attractive. It enters. Well, I need to then generate the x1 column, which since this is the first pivot, I can just grab the x1 column, but I'm pretending like it's not the first pivot to do the ratio test. Okay, so how do I get that column? I multiply b inverse times the original a1 column. Oops, I don't mean to slash it. I'm trying to underline it. Well, since it's the identity, this is that generated column. Okay, so we get this generated column. Why do I need this generated column? Because I'm going to stick it. See, I stuck it right there. So this is my b inverse. This is my right-hand side, which is b inverse b. Okay, and this is all of the table I need. I do not need the rest of the A matrix. Okay, so look, I can do the ratio test. This is why I needed this column in the right-hand side to do the ratio test, right? So typically when I write these, I just keep up with b inverse and the right-hand side, and then I generate the column. Where did I get A1 from? Well, because I calculated the cost. What was the most attractive cost? X1, the first column. So A1 plops in here, or B inverse A1, and then I see where am I going to pivot. I know I'm going to pivot here, but on which one? Slack 1, slack 2, or slack 3? Well, ratio test. 48 over 8 is 6. 20 over 5 is 4. 8 over 2, 20 over 4 is 5. 8 over 2 is 4. So which one's the smallest ratio? Yeah, so x3 is the one to leave. So I'm going to pivot right here. Okay, so that's all I have to do then. I calculate the cost. I generate this column. Column generation is extremely powerful for a lot of the higher level linear programming techniques, especially things like Danzig-Wolf decomposition for when you have massive linear programming problems. So I just perform a pivot. Okay, so make the pivot. Look how fancy I got. I even was able to put a circle in there. So make the pivot here. Okay, so when you make the pivot, remember, making a pivot needs to make this an identity column. You see, I don't need this generated column anymore. I can drop it, but I wanted to leave it in there just to show you that that's what you're doing to make a pivot, right? So this row gets divided by 2. 0, 0, a half, and 4. So I'm updating B inverse and the right-hand side, which is B inverse, lowercase b. Let's see, then I need to multiply by -2 and add up. Multiply by -2, that'd be -16, and add up, that makes 4. Multiply by -2 and add up, that will make -2. Then I need to multiply the top row, multiply this by -4 and add up here to zero it out. -4, add it up, that leaves you with 16. -4, add it up, that puts a -4 there. So just a basic pivot. And so now I have done all the work I needed to. I have updated the list of basic variables. X1 is there now. I have updated the right-hand side. I have updated B inverse. So we've done one pivot. Now I'm ready to do another pivot. Okay. So let that soak in a second. So all I have to do a pivot, calculate the new reduced cost using these formulas to see which one enters. Okay. So let's check the new reduced cost. That's on the next page. So there's the new reduced cost. Do I have any attractives? Yes. Right in here. X3 is attractive. It's the only one with a negative reduced cost. It's the only one that's attractive. So X3 is going to enter. So remember, I need to generate the third column. I can't. So this is the original A3 column. I take the new B inverse and I multiply it. So this is the generated, the new. It's what we generated. Whoops, dyslexic. Generated. This is the new A3 column. The third column, if you were to keep up with the entire table, this would be the third column right here. So I take it and I plop it in between my new B inverse and my new right-hand side. See, this is the generated column. This is the updated A3. This is the right-hand side. And this is my B inverse. All of these are updated. Ratio test. Don't pivot on a -1. So let's see, 4 divided by a half or 4 divided by 0.25. So this one wins. So I'm just going to pivot on that. And this is what I have. So this is my new B inverse and my new right-hand side. And I updated, notice I updated the list of basic variables so I know what I have. So look, I'm doing the simplex method without keeping up with that massive table. That massive table had 6 columns in it, and a right-hand side, and the cost, and the objective function value. I don't have to keep up with that. I'm pivoting on a lot smaller of a scale here. I'm having to generate the column I need to see where I pivot and to make the pivot, but it's not taking me that much effort. Okay? So there's our new B inverse. There's our new right-hand side. So once again, we're ready to just check the cost. So that's the cycle. You check the cost, pick what enters. So once you know what enters, that lets you know what column to generate. Generate the column, and all you need is the original column, front multiplied by B inverse. Pop it in there, do your ratio test, and pivot. So I don't have to pivot on the entire thing. Okay, so let's check reduce cost. So I take the new CB, the new B inverse, times A minus C, and these are reduced costs. Notice no attractive, typo, not attractus, but attractive. No attractive variables. What does that mean? That means you don't have your, you have the optimal, Okay, so we're done. We're at an optimal. So let's calculate the objective function value. How do I calculate the objective function value? That was that formula CB, B inverse B, right? Pretty simple. So there we go. We get to 80. I will say this is easier than all of this, because don't I have this piece of the formula already sitting right there? I have the updated B inverse B. So I just could multiply that by 0, 20, and 60. Let's see. Yep, 280. So we have finished the revised simplex. Okay, pretty awesome. The revised simplex does save a lot of. So say this was a massive problem, we're writing about half as much. If it's a massive problem, we'd be writing a whole lot less. So it's pretty neat. This is the doorway to a lot of higher level advanced LP topics. Now, I'm not going to put this on your final or anything like that. I just wanted to show it to you. So you will not be tested. We don't have enough time probably to slip another one of these homeworks in there. So don't stress if it looks overwhelming. I'm not going to make you do it. But I wanted to show it to you as a powerful kind of method and teach you something. And honestly, it's really neat if you have the time to work this problem out and put a line down the middle of your paper, and on one side do the pivots with the entire table, and on the other side do the pivots with the revised simplex. You will see that this matrix is, so this is our final B inverse. If you were to write out the entire table, that's going to be sitting in the same spot the entire time. Whoops, negative 0.5, negative 8, negative 4, negative 1, positive 1.5. This would be this part of the table sitting right here. So literally, it just really all that matters is keeping up with B inverse. So anyways, Friday, so this is Wednesday's lesson. Friday, I will be sending you an email with a kind of a topic list of everything you need to be prepping for the final. I'm going to send that instead of a video, so this will be our last video together. And then Monday, I will open the final exam. So no class Monday, I will just start the final exam then. It will be due on Wednesday. It will be a normal final. I will send it to you. You print it, or you don't have to print it. You just write your answers out, write your work out, and upload them back to me in Blackboard. And I will grade them and put your grades in, okay? So I will send you a lot of information on Friday on how the exam will go. So y'all have a wonderful, wonderful day, night, morning, whenever you're watching this. I'll see y'all later.